energy. So what you can see here, if you take a closer look, is roughly a picture of the entire campus and all the different systems that are using energy, including the electrical grid and the recyclable grid, all of the different systems that are involved with using and controlling energy. And so what are the goals there to try to achieve that goal of 20% savings? What is some of the challenges to do that, some initiatives, and what would be some of the best lessons learned and best practices there? This section, or this work group over here, will be working on reliable energy. So this is Lund's energy and Eon, starting with some concept there, but what can we do to have a reliable grid? And this takes through the entire electrical grid, and so we have two people there. So Jacques, who's done a lot of very complex electrical projects in Africa, Central Asia, around there, will be working with us there. Then this afternoon, we'll break into just two groups.
That's happened with the availability for being RF and cryogenic. Okay. And the bad guys that mess things up are cryogenic.
Some of the major when it comes to
some of the things that we talked about is we wanted to recover as much heat as possible. Again, to the first approximation, there is 40 megawatts of power that's going into this thing. A very small percentage of that actually ends up on the beam, and the rest of it we have to do something with. And we made a commitment to use as much of that as possible. Obviously, we want to have reliable cooling. The biggest challenge is how do we define what is as much as possible? In other words, what is the break point? When do we decide that, it just doesn't really make any sense for us to recover this heat because it's too expensive? How do we make those decisions, and how does that end up affecting what the overall cooling system looks like? We have how much power does it cost? We've got heat pumps that we're going to be taking lower temperature heat in.
But it happens to be at a frequency where you allow the least flicker in the standards. This is because we can get what is called a subharmonic or subsynchronous resonance, which is damaging turbine shafts if we are unlucky. So if these 14 hertz go back on the grid, we can maybe break the turbine shaft somewhere in Oskarshamn. Cool. As a phenomenon, it's extremely cool. On the other hand, it's unwanted. This is some of the things that we have been looking at. And challenges, well, from the EMC side, our biggest challenge will be the grounding system. We do not want into
usually you don't have access to the generation modification. So usually we treat it as
So let's push that down then. So
it sounded like it's a certain amount of
It's a rat hole.
This is totally
operation.
No, I think
versus weather and temperature, right?
You designed it so.
I understand.
And so
Just from a systems engineering standpoint, make sure that communication process is defined.